Okay, so the only thing we're adding this week is discontinuities and graphing. Remember AH and K? All right, so we're going to use that this week. Okay, so go ahead. Oh, I got to pass off. Well, before we do that, go ahead and write 3 types of discontinuities and then just make 3 X and Y. So I'm going to explain what each type looks like, and then we'll work to identify it. So discontinuity just means not continuous. So if something is discontinuous, it's not continuous. Excuse me. Which means we will have to lift our pencil when we graph it. So we have to lift pencil when graphing. So it's not a continuous line, it is discontinuous. So if we're trying to graph it, we have to pick up our pencil. There's 3 different types of discontinuities that you need to know how to recognize, and you also need to provide examples of. So the first one is an infinite discontinuity, and that's where your graph approaches infinity. It approaches plus or minus infinity. So I'm going to draw an example of an infinite discontinuity. So first of all, when you have an infinite discontinuity, you have a vertical asymptote. So let's just say we have a vertical asymptote here, and we'll say this point is -2. So let's go ahead and draw in a dashed line, a vertical dashed line at -2. So the graph is going to approach from the left or right. You can have it where the graph on both sides is going up. I'm going to draw 3 different ways that you can have it. So that's one example where both sides are going up on both sides of your asymptote. Or you can have it where, you can have it where one side goes up and one side goes down. Okay. That's also an infinite, or they could both go down. The main thing to keep in mind is what is happening at this point. At a certain point in the domain, the graph just makes a U-turn, or not a U-turn, but it makes a sharp turn and goes straight up or it goes straight down. So notice that if I were to graph this, right, if the blue is the graph, in order for me to fully graph it, I have to lift my pencil. That's a discontinuity. So that's the first one. It's an infinite. The second one is a jump. And a jump occurs where you have a quick change in Y. So let's draw this one. Let's say that at x equals, again, I'm just making up this number, 2. So I'm going to draw a graph that from the left is constant. And then when it gets to 2, it stops. And then it jumps and does something different. And what it does could be anything. It could be constant again. It could be a parabola. It could be a line. I'm going to draw an example where you have a jump and then it changes to a line. So notice how at this point there's a break. The graph is doing 2 different things. Now what I want to make sure you see is that in order for it to be a function, if you have a jump, you cannot have 2 closed circles. Because at x equals 2, y can only have 1 value. And if you have more than 1, that's not a function. And the last one looks like a hole in a graph. So let's just draw a parabola. Let's draw a upside down parabola. And then at one point in that parabola, I'm going to make a break in it and put a hole. So we'll again say, we'll say that that's 2. That means I have a function, but there is a point in the graph where x does not exist, or the function does not exist. And we show that by including a hole. It looks like an actual hole in the graph. Okay, so let's go ahead and try to draw some. So let's draw some. On our next homework assignment, you're going to have to, the next homework assignment is a worksheet. I'll pass that out real quick. And and on the test next week, you'll have graphs, and you'll have to just create graphs that have those. You have to know how to create each one of these discontinuities. Okay. All right, so let's go ahead and draw functions with the following discontinuities. So we're going to draw an infinite at x equals 2, a removable at x equals 3. Now, when you make a removable, you choose the kind of graph. It could be a parabola, it could be a line, it could be a... The main thing to keep in mind, though, is that it has to be a function. So whatever you create has to pass a vertical line test. So I'll give you a second to copy that down, and I'll pass out the homework. So when you see infinite discontinuity, I want you to think vertical asymptote. So I'm going to draw in a dashed vertical line at x equals 2. And then you decide if it's going to go up, 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 down, down, up, or down, down. It's just at this point you have a function, and it has to approach infinity at the asymptote. Okay, so here's a couple of things. Like, this is a very common mistake. Is to try to draw something like this. Like, that's not a vertical asymptote at x equals 2. Because at 2 is when it should be going up to infinity. Okay? Or down to negative infinity. So that would be wrong. But that's a common error that I see a lot. Okay? So at x equals 2, I can either make it go down, and then one side can go up. But the main thing I'm going to look at is it a function? And is it an infinite discontinuity? So for removable, you just need to draw a graph. You can create any graph. You can be creative. Create any graph. It just has to be a function. So for example, this would not be okay, right? Because that graph is not a function. It doesn't pass a vertical line test. Yes. A parabola is a function. A straight line is a function. You can draw a straight line. You can draw literally anything. It just has to be, you can make anything. It just has to be a function. So if I keep with this line, where do I put the hole? The hole has to occur here at x equals 3. So then I'm going to go to 3, and I'm going to put a break. But you draw a parabola. You draw whatever you want to draw. And that would be an example. So that's one example of a removable. And I want you to create exactly what you see me creating. I want you to try to create something. It could be a parabola, but you have to put the hole at 3. That would be okay. It could even just be a constant, just like a straight horizontal line. That would be okay. And then you have to put the hole at 3. So there's a lot of different functions you can draw with a removable discontinuity at 3. All right, let's go ahead and draw a jump, and then we'll do another infinite. Actually, we'll do a jump. We won't do the infinite because I want to make sure we have a chance to do that clip art that I passed out. So we'll just do C. We'll skip over that one. So let's make a jump. A jump is kind of tricky. So for a jump, you have to do two different functions. So let's say we're going to do any two functions. You can have a constant. So you just have two functions, but it could be any two. So I think I'm going to do a parabola. So I'm going to draw a parabola, and the parabola is going to stop at x equals -4. So at x equals, so I'm going to make a parabola that does that, and it stops right there. And then at that part, you jump down, and you can make another parabola. So you can have like a parabola that's broken into two pieces. That would be okay. I'm going to draw a lot of different ones, and you all can I just want you all to recognize. The main thing is that it's occurring at -4. I don't have two closed circles, because if you have two closed circles, that's not a function. The definition of a function is that x has only one y value. So if I have two closed circles, that means that that x equals -4 will have two different y values. That's not okay. That's not a function. So that would be okay. You can even have like a line, like that's a function. A parabola and a line. You can have two lines. You can have a line that comes down, and then another jump up and go like that. There's a lot of different ways you can draw a jump. So those are just some examples. Okay, let's go ahead and draw. I know I'm jumping down. Let's do G and H, where you have two different ones. So we'll make a removable and an infinite on one graph. So we'll have two different discontinuities. So when you see infinite, I automatically draw a vertical asymptote at +4. So I'm going to draw that in. And remember, I said with the vertical asymptote, you just have to you're approaching infinity or negative infinity at that point. So I'm going to draw a graph that on both sides is going down. This is a rational function, and we're actually going to draw these out. Thank you so much. You can open it. Thank you. So I'm going to draw that. Thank you. Okay, and now we have to put a removable at -3. So the graph I drew at -3, I need to erase it and put a hole. So -3 will be right here. I'm just going to erase. I'm going to erase that little piece and put a hole right there. And you have two different discontinuities in one graph. There you go. That's it. All right, I want you to try to draw H by yourself. Because when you look at the homework, you're just drawing discontinuities. These are test questions. So you're going to have to draw discontinuities on the test next week. So take a moment, try to draw H, and then I'm going to come around and just look quickly at what you created and tell you if it will work. So the first thing is when you see infinite, I would draw in my vertical asymptote at -3. And then I'm going to draw a graph where on both sides, immediately to the left of -3 and immediately to the right of -3, it's either going to go up or down. A lot of you were doing stuff like this. That's too far away. It has to be at the asymptote. So on both sides, I'm going to draw something. I'm going to make it, let's just say it's going to go up. So I'm just going to do this. Okay. So that takes care of the infinite, right? But for the jump, that means at 2, this graph that I have on this side has to stop at the 2. So at the 2, I'm going to stop it and then do something different. So it does this, and then maybe it jumps down. And notice that it's not two closed circles, too. If you have two closed circles, that would be -0.5 a point. It's going to jump down, or it could jump up. Matter of fact, let's have it jump up and make it, like I couldn't do this. Like, why would that not be okay? What's wrong with that? That's not a function. This would fail the vertical line test. If I draw a vertical line right here, you see how that blue line is going through two graphs? That's not okay. So I got to make it swing to the right. And that'll be okay. So again, when you're doing this, I know that a lot of you all just copy each other's homework, which is showing in your when you're nervous about your tests. But when you're doing this homework, you need to do it yourself, because you all shouldn't have the same graphs. And if you do, then I'm just going to, divide it 50 points by 28 and give everybody 2 points each. I don't know. So do your own work. Do your own work. Okay, let's try to go ahead and glue down that clip art that I passed out. And we can identify, let me pass out the glue sticks. But I think I want to give you guys one more, though, before we do that. Let's do one more, because I really feel like you all need a little bit more practice. So I'm going to give you one more. I didn't hear you. No, not yet. I'll pass it out. I'm going to give you one more, and then I'll pass it out. So let's just call this next one. Let's say this last one, I want you to draw, I want a jump at x equals -2. And I want a removable at x equals 1. Try to draw that.